So yes, as mentioned, I'm Sandy Antunes from Applied Physics Lab. Several of my teammates are here as well. Peter Shumate, Jeff Bradford, Sarah Rourke, and Lisa Knowles is joining the team in here as well. They'll be monitoring the chat and answering a lot of the technical questions that come up and then interrupting me as well. And then we have a dev team consisting of people at NASA Goddard as well as at APL. And then assistance was provided by Shawn Polson of a group called Python and Heliophysics, reasons for which you will discover. This is a walkthrough and hopefully demo about how to spin up a cloud-based science platform for doing a workshop or a summer school or other pop-up, ad hoc, or short-term types of events. We've run multiple short-term cloud science platforms for workshops, for week-long workshops, doing daily demos, going to a conference and spinning it up. And I'm going to talk about the underlying tech stack for the people that want to talk tech, a fair bit on logistics and operation of how do you do a cloud platform for a workshop in terms of security, cost, onboarding, handling problems that happen at runtime. And we'll talk also about specific lessons that we learned. And also you can all try it. There was an email sent out that most of you hopefully received that gave how to set up an account on the demo platform that we set up. If you didn't receive it, by slide 9, we'll have a reminder on how to set up an account and log in. Thanks for those that pointed out I had the wrong date and listed September 24th. Yes, it's valid for September 25th. And I expect this to take less than an hour for the walkthrough part, depending on questions. And then we will go to open discussion because I'm very interested in hearing experiences from others of you doing cloud development as well. With that in mind, we think that the audience for Science Cloud Gateways is other people developing gateways, but I'd like to do some calibration. And no, we're not going to force everyone to participate for those that tend more introverted. But if you could please type into the chat the science domain that you work in or that you develop for, just so we can see sort of a scrolling ticker tape of the kinds of things, kinds of domains that you all are developing. So for example, we're heliocloud.org, so we develop for heliophysics, solar physics, sun research, space physics researchers specifically. But some of our work connects with astrophysics, with the people doing the Fornax initiative, etc. So we're still rooted strongly in the NASA and the space science domains. So we'll give a minute or so for people to type in the science domain or the IT domain or similar that you're working in for your interest. And partially this is my curiosity, who is the audience here, and then also to see, how much should I be leaning towards, hey, here's cool things you can do for science versus, hey, here's cool things you can do for gateway. All right, so already a mix of core HPC and software engineering, some CFD and other science domains, some higher education. Yep, please keep typing those just because I'm fascinated by what the audience is, and this will help me understand things. All right, and then second, while you're thinking about that and typing that, you can fold into that, what is your reason for being here at Gateways? Are you developing a portal? Do you just want to nick our software because it's open source and you totally can? Are you an educator wanting to run workshops? Are you a reseller who wants to nick our software, which is open source, so you totally can? Are you just curious? Are you a rival heliophysics cloud, which is seeking to secretly undermine us by nicking our software, which is open source, so you totally can, etc. Ooh, curious. Lots of curious cats. That's a good thing. And again, if you can just casually type in these things, it'll be very useful. And then also, of course, your credit card number. No, absolutely kidding on that. Do not put your credit card number in there. But we are an AWS, Amazon Web Systems based cloud. And so they do microtransactions and charge for everything. So I just couldn't resist doing that. All righty, for those of you, especially the just curious, who want the too long, didn't read or you're trying to decide if you want to stay here, or you just want the end point. We're an AWS-based platform. So a lot of what I'll be talking about in terms of infrastructure and tech stack is AWS. In terms of operation, applies to everything. What we found is for short-term workshops or pop-ups, a Dask Hub with Jupyter notebooks and preloaded data and tutorials scales really well for events that you want to run. That's part of the advantage of cloud is you can run an event for 12 people or 150 people, and it just scales without you having to really do any sysadmin or backend. You can spin up a HelioCloud type environment in around 3 hours if you know what you're doing. So it's a half day work or maybe a half day spread over 2 days if you have to do questions and such to set up something for your event. We found for running the PyHC Summer School, we had 150 users, of which 80 would tend to be on concurrently. And it only cost about $700 to have the whole cloud environment up for that week in terms of AWS cost. So if you're an educator and you're like, hey, how much would it cost to do this? It was about $700. When I go to the cost breakdown, you'll find out it was only about $2 per user. The rest was just the base to have a cloud. Teardown's the part that we're still a little bit tweaking because there still is some manual stuff because AWS doesn't like you to leave their ecosystem. So they always leave a few little hooks in just in case you want to come back. One key thing that makes what we did applicable to other domains and other people is our stack is a Pangeo influenced, very generic stack that happens to have a container with all the heliophysics software. So HelioCloud and HelioCloud type approaches, including our software, work great with other containers if you want to put in there. So a lot of what I'm saying is not just this is what we did, but applicable or being open source, nickable for other domains. One walk away in setting up for a workshop is you really want to test the container. The cloud part is probably very stable, but you need to test the container against the people that are actually attending your event and presenting because speakers will be your biggest problem. I'll talk about trust issues, but you basically have to manually monitor the users and trust. Trust will be a fun thing to talk about. And then I'll cover some anecdotes. And of course, all the code is at heliocloud.org. If you want to try out our cloud environment yourself, go to pyhcschool.heliocloud.org and click on sign up and register with a username of your choice. Please know little Bobby tables there and the email that you signed up for the conference and choose a password and it will set you up. All right, having gotten past the summary and the highlights, as mentioned, I'm going to talk technical. I will do the obligatory who we are, our platform, emphasizing that we're open source and go into our tech stack and talk a little about installing, whether it's easy or not. I did an install 2 years ago, just following the team's instructions before I really understood the underpinnings and was able to do it. So we really are aiming for that golden standard of, one button install. I'll go through the logistics, especially the container and how to onboard lots of users. And then I'll talk about runtime issues to look out for, costs and outcomes, attendee feedback, and then we'll get into Q&A. And as mentioned, I don't want to do my talky part for too long so we can get to info exchange. And of course, you're welcome to fork our software and discuss further. And there's a splash of our webpage for what HelioCloud is. Feel free to interrupt anytime via chat. Jeff Bradford is going to moderate the chat and answer questions, or tell me, hey, Sandy, you have a question, or you can raise a hand in Zoom if you prefer to do verbal questions, because I'm happy to have this be more back and forth. So HelioCloud is funded by NASA, but it released to the community as open source, and it is, for those doing cloud, something that looks probably very familiar, a Dask Hub Jupyter type environment on AWS, influenced and based off Pangeo. So it's a shared architecture. And the idea is there is no one HelioCloud. NASA runs a HelioCloud, APL runs a HelioCloud, and these different cloud environments enable researchers to do work, but also to share work with researchers in other HelioClouds. through data sharing, and through having a similar container. So the common software environment is one of the big advantages of it, plus the just works kind of thing. And of course, the cloud is the gateway to high performance computing with dask bursts and the ability to throw lots and lots of CPUs as needed. The full HelioCloud has notebook environment, or people that know what they're doing can just get a VM up in the cloud and start doing stuff through SSH and terminal. For this pop-up, we'll be focusing on the Dask Hub notebook environment. I'm guessing everyone here is already a convert to the idea of cloud, because you wouldn't be here. But if you are not a convert to cloud, the point of cloud is someone else's computer, and you generally want to do cloud when you have a situation where the maintenance or setup or operate or sysadmining would be expensive or tedious based on the scope of what people are doing. You know what I mean by that? If you have 2 or 3 modelers at your institution, putting them on the cloud, letting them throw 16 GPUs or 100 CPUs at their problems when they need it is great. If you're an institution with 100 modelers and simulators, you might want to do on-prem. That's all up for you. However, the main thing for any cloud use is setting up an environment on a cloud provider like AWS takes a lot of cloud engineering knowledge. Essentially, you have to have a degree in DevOps, and it takes a lot of dev time to do so. So using other people's solutions, like Pangeo or HelioCloud, is really what NASA is working to develop, so that institutions can get cloud without having to be NASA, without having to have cloud engineers. So someone at a small university could very easily set up a cloud environment for their summer course or for their group of 6 researchers to bring that capability in. So it's sort of an equity egalitarian thing. The architecture is cloud, infrastructure as code. So we're building on top of AWS. We're using CDK for HelioCloud. We interact with the astrophysics Fornax, who are doing Terraform. The whole idea is automated deployment, again, so you don't have to hire cloud engineers. You just need a part-time sysadmin. And then at the end, you have a Jupyter Notebook environment ready for multiple users. If you've never used a Jupyter Notebook environment, great. You got to set up an account on HelioCloud as part of this demo, and you will get to see this. We specifically in Helio use cloud for classic cases, big data. You want to look at the Solar Dynamic Observatory's images of the sun for 1 year in 1 wavelength. That's 2 terabytes of data on 120,000 files. You might fit that on your laptop, but it's going to take 25 hours to analyze. Maybe it'd be better to not transfer it to your laptop, because if you add 5 wavelengths in, well, now you're into 10 terabytes. If you want to look at 10 years of data, you're now at 100 terabytes of data. So big data types of problems. Open science is a big driver for cloud. If everyone's developing in the same environment, especially Jupyter Notebooks, notebooks are very easily shareable to allow others to replicate and build off of work. And the shared container means everyone has the same environment, so scientists and users aren't fussing with environment all the time. And we're working on building collaboration, cross-cloud compute being the magic thing. We haven't gotten there yet. Open source modules being there. And again, for this tutorial, we're going to talk about short-term pop-up, one-off, or not up 24/7 versions of a cloud environment. HelioCloud is, as you can see from the picture, a very standard Dask Hub Jupyter environment with Jupyter Notebooks. It has a scientific computing focus, primarily Python. We reluctantly support IDL or Fortran when people want, but we're really trying to push people to Python because Python plays so well with the cloud ecosystem, and all the examples I'll deal with will be Python. It has the ability of bursting. Look, the word GPU got a little wiped out there, but you can throw stuff onto GPUs, more powerful CPUs, lots of RAM, etc. Totally stealing from Apple. We want it to just work for researchers, because that's what scientists want. They don't want to become cloud engineers. They want to just do their work. Postdocs probably want to get to their work so they can get to their research. Grad students definitely want to get to their work so that they can get their degree and move on. We provide a lot of tutorials for HelioCloud, specifically for heliophysics, which is crucial to train up non-cloud users on how to do cloud. And then part of HelioCloud, which is not part of this, is we're going to have 8 petabytes of data available by 2025, certainly more than one can do on a laptop. And there's over 125 science users using this platform already, plus 80 simultaneous in the pop-up one. If you haven't yet set up an account, here's the reminder: go to pyhcschool.heliocloud.org, sign up and register, and you can be in the environment. Again, we're providing a virtual software environment that's containerized with the Dask Hub backing so that users can do science from their laptop. In the case of pop-up and workshop events like PyHC Summer School, that was a 5-day, 8-hour-a-day event with a large number of synchronous users doing a Zoom with people speaking and then following along. I did mention we talk a little bit about infrastructure. Here is the very common diagram that you would see of how things are set up. Dask Hub, storage, you can have standalone VMs. Users should never see this, and really someone setting up the cloud doesn't need to see this. This is more for the dev people if you're like, oh, what kind of setup are you using? All right. So some of the things that we did for the PyHC Summer School, which is the primary example. PyHC is the Python in Heliophysics organization that acts, they're funded by NASA. They don't create software. They are a place where people creating software for heliophysics researchers in Python, open source. They're a clearinghouse for all the open source packages. And every 2 years, they run a week-long summer school. Once we did it in, I think, Paris, once at LASP. And people can attend remotely or in person, but it is full days where lots of people are there all live at the same time. So in order to get this going, we had to set up a PyHC Summer School instance. We did a minimal cloud setup. We didn't have things for generating access keys. We didn't have our data registry. We didn't do all the full monitoring tools that you would need for a full build. We did use KubeCost to do cost monitoring, and we set it up at the URL. We deployed it in US East 1 as a region, and we used Route 53 domain off of our main account so that we could have the domain going. We had to play a little around with AWS access permissions, IAMs. We found that we wanted to have nodes warmed up and ready because we had 80 people at 9 a.m. all spinning up a node. And this was not a good time to wait for nodes to spin up. Likewise, we use the slightly more expensive on-demand rather than spot instances, because if people are on at 8 hours and they want their state saved, we didn't want the ambiguity of them suddenly being switched to cheaper machines just to save some costs. And then we also lengthened the idle time that nodes can be up from our default of 2 hours, because with students being there 8 hours, they might be listening for a while, they might take a lunch break, but we wanted them to save their state. So that's sort of the logistics cost profile we used to set up. I'm going to go through 3 slides briefly with install and then see where we are, but there is a YAML file that you put your specific configuration in, your region, your domain name, your contact people, etc. Then you go into the AWS console to set up the actual domain, in our case, pyhcsummerschool.heliophysics.net, and to grab the IAM role that is needed in order to have the permissions to actually run things. So, here you can see VS Code as the IDE on the sysadmin Sarah's local machine, and then she popped into the AWS console, got set up and got the information she needed, fed that back into the YAML file. She went back to the IDE and ran CDK scripts, which take a while to run. They just sit there and chug in the background, and they give you how far they're completing. And if they throw an error, we have some advice on the errors, or that's where it might take a little bit longer to look up why you have a specific error, which are frequently permission or IAM spaced. But again, you're running from your local machine, the CDK scripts. When that is done, those scripts will have a cloud environment set up for you so that you are now fully set up with the whole cloud working off of one AWS account. The next step is you then install Dask Hub on top of that. So to install Dask Hub, you go back into the AWS console, you launch an instance, And then you run the provided scripts, the Bootstrap and other scripts, and some EKSCTL commands that we give in the documentation to actually bring up the Jupyter Task Hub. We're not doing anything special with Jupyter Task Hub. So this is sort of the valuable part of our open source for people that are doing cloud development, because this is our underlying CDK to try to do one script and one button install of a working cloud environment that can be done with multiple users. This is just straightforward setting up Task Hub Jupyter. Same way you would for Pangeo or Task Hub Jupyter or just about anything else that happens to work with our underlying CDK pinnings. Alrighty. So again, the goal, multi-user cloud environment with easy sign-on Jupyter notebooks backed by a single AWS account. Gonna go to our repo. So the GitHub is linked off of the main project site. So here's the website for the main project site, HelioCloud.org. And if you go to code, it will take you to the GitHub repository. We have several repositories. The one that I'm covering here is platform, the core platform code base. Because we do heliophysics, platform is the non-heliophysics part. So those of you from other domains, that's what you need. The heliophysics stuff is our runtime. That's our specific containers, which we use as a Helio base one. And then there's a machine learning TensorFlow one and a machine learning PyTorch one. I almost said TensorTorch, which would be an interesting mix there. So those are the containers that are available, and we build those containers with the community. But for those of you in other domains, you could do a different runtime container. It's just a container. You just have to modify the install scripts to bring the right container into your Task Hub environment, as cloud is cloud. The platform is what you would want. And obviously, we provide science tutorials because if you give an institution or people a cloud and they're just faced with a blank notebook, they'll be sad and they'll go away because they won't know what to do. So we have a lot of tutorials for that. And then we have Helio-specific user tools and a way of accessing the petabytes of data that's in there. But core for getting a platform to pop up would be going into the platform GitHub. And in addition to cloning it, this is where we have our installation instructions. I'm not going to walk through this in depth because you can go to heliocloud.org and go into our GitHub and look up platform and get to this README and see. But this is the installation ones. We have what the requirements are. We're using Docker containers currently. We have hot links going to where CDK is. If you need to install CDK because you probably don't have that. Some notes that we found them running off of VPN and certs. We go into IAM roles and we talk about our IAM policy. And we give an example of the IAM policy that you would say in AWS to get this to work. And we note this is a very open role we use for ours and not for the default users, but this is the open role that you have to do. This is not the IAMs for the users. This is the IAM for setting up the platform. Obviously, you have to choose a region. Then we talk about configuration. We provide a default YAML and an example YAML that you can now modify for your specific build to give it names, etc. Identities, that's where you'll put your AWS account in. Remember, this is all running off one person's AWS account. Those of you using our example portal right now, you're running off of a NASA provided one. We give modification tips and then deploy. You run CDK. It should work. If it throws errors, the errors are hopefully informative. If not, you can go and you can file an issue here and we will take a look at things and see if we can help. And then there's a way to check, which will tell you that hopefully the components that you requested are there and compiled. Once you've gotten that did not actually deploy it, that basically pulled all the pieces, compiled everything, and set up for deploy. You then click CDK deploy and just walk away. It can take, 10 to 30 minutes for CDK to slowly chug through everything that it needs to get going. And then we have some reinstallation. And then again, separately, now once you have the HelioCloud stuff from our platform up, you can go to Dask Hub, and we give instructions specifically for getting Dask Hub up on our platform. How do you do this? This is where you do CDK to get Dask Hub in. Then you go into the cloud that you've set up, an EC2 instance on your cloud, either through console or the CLI, and you stand up a Kubernetes cluster using our scripts. I mean, yeah, it uses EKSCTL and Kustomize and similar, but it's really used the deployment scripts, and it pretty much builds it. There's some decisions you get to make about storage. We have 3 types of storage. There's the separate user space, and then there's shared EFS disk that people in that HelioCloud can access. And then doing S3, aka Amazon's big cheap storage, is something completely separate that is not part of this. So this is really just to have your main disk and then a shared disk that everyone can use. Let's see, login, and then you can create users, but if you have gone to the URL that I keep giving for getting it, you can see that you don't have to create users here. We have a front end to Cognito that you can create users in AWS if you want, but you can just use the existing tools within it. So that's installation in a nutshell. And again, hopefully by now you're in the PyHC Summer School HelioCloud, and you can choose an instance. And one thing that's very different from our scientific production versus our pop-up is, for our pop-up, we only had one server type. So if you're on a HelioCloud that an institution spins up, there's typically 6 server types, ranging from a notebook-sized server to something with a lot of CPUs and a lot of RAM, and then the GPU equivalent, a small GPU to a large, fast GPU server. And the users are faced with a menu of 6+ machines to spin up. We intentionally did not do that here. Because for a pop-up workshop, you want to have as few decisions from the users as possible. So going on to the full-sized HelioCloud to show an example of what I mean. These are the servers that would be available to a fully fledged HelioCloud. For the workshop type or the temporary one, we only did the CPU server because, well, actually, I think it might have been either CPU server or large CPU server. This was to keep costs down. We're still looking at this, and I'd love to hear either in the chat or people speaking, if you have a cloud and you're offering multiple machines, what do people gravitate to? Because we find some people are like, oh, I'll start with the CPU server and see what it breaks. But unfortunately, especially with scientists, we suspect we have a lot of people that are like, my research is big, I'll just choose the biggest one because you can never have too much server. And now you're shifting from pennies an hour to dollars an hour without it actually being like right sized to their task. So we would love insider feedback either now or reach out to us later about how do you guide users to the right sized server? And obviously the answer for a pop-up workshop is you only give them one server that you know will run everything that you're doing. And in this case, we chose a 12 gigabyte RAM, 2 CPU server because it ran all of the tutorials that were going to be used in that 1-week workshop. Okay, hypothetical time. Say you're there and you're like, okay, I'm going to run a workshop, or I'm going to run a summer class, or I want to put a cloud up for this project that is going to run for 4 months. Have an issue board, but also have a checklist. You will forget things if you're setting up a pop-up cloud thing if you don't have a checklist. And some of the things that we looked at is we had to make sure we had enough memory to run the tutorials. We had to massage our speakers, essentially make sure that our speakers were delivering their stuff in advance. Always a problem if you're doing a workshop, you have speakers, you're like, we need the content in advance so that we can make sure everything's on the system to support it. and you're all set up. And then one speaker, the morning of their talk, says, "Oh, I changed my tutorials that I'll be doing for all the students. Can you get the new tutorial for them? Also, I need 3 new packages installed in the container." And at that point, you can't change your cloud, you can't change your container. It's too much to expect. So you have to have a certain ruthlessness with people that are presenting or teaching in terms of how you're going to handle last minute changes. So a lot of actually running a workshop or setting up for a course is really get your container nailed down so it supports the final tutorials or material that people are going to go through. Because if suddenly someone's like, "Oh, hey, I decided to add PyTorch last minute," and your container doesn't support PyTorch, that's a hefty install that will take away from participant or student time when you're doing that. Other things in your check-in, make sure you have people support, that sign-ins are set, that administration is set. To do today's tutorial, I made sure that I had other people from the team here quietly and, working away in the background without credit just to get this done. So Jeff, again, is tracking the chat. Um, Peter and Sarah are looking at the cost and security and that everyone's being onboarded and user accounts, etc. If you have additional things, I'm going to talk about how we added a quiz-like challenge ladder. Then you want to make sure that's set in. You're going to want to have cost tracking for your workshop because it's always nice to know how much these run for when you propose to do the next one. You want to make sure you have nodes nice and warm and up and running so that everyone can onboard promptly at 9 a.m. or 1 p.m. or whatever time it starts. Decide how long nodes should idle before they shut down. Because when they shut down, you save money. But if you have a shutdown of 30 minutes of inactivity, everyone's losing 30 seconds to 5 minutes spinning up nodes. Because remember, if a single user on the cloud can get a node to spin up in, say, 20 seconds, if you have 80 people doing this at once, even if you pre-provision things, there will be lag. AWS is not instant unless you pay extra for everything being instant. We had to decide, did we want to keep Dask burst capability, the ability to launch a Dask job onto 50 sudden worker nodes, which would be very expensive if 80 people suddenly decided to play around with 50 worker nodes for 8 hours just for funsies. We actually decided to keep the burst in because it was built into the cloud environment, but we didn't advertise it. However, if people found it as a stretch goal, then, bonus to them for being good learners. We had an additional machine learning demo for Friday that required a larger, slower container size, so we tested that to work, and then we considered ourselves ready to go. Some things that we found in running a workshop, 12 gigabytes was the minimum RAM that worked for tutorial student level things. And we found this by prototyping. So if you're doing a workshop or an event or putting up a cloud environment for a specific task, really profile what the server needs are because you want to right size it and you want to leave a little bit of headroom there. Memory was pooled, which was kind of interesting. You could have your 12 gigabyte machine and be using 16 gigabytes of memory on it because of pooled memory. But if enough people exceed the average of 12 gigabytes for a given pod, then you could actually crash 4 to 6 users because of how AWS cluster things in pods. So something to be aware of is, do you want to have 1 user per Amazon allocated pod, or do you do the more typical, there are a few pods up and running, and then Amazon provisions, individual sessions onto them with the risk that one person can crash many. That's sort of a trade-off to do. Container size matters. If you have a container that's in and someone on my team correct me if I'm wrong, but sort of the 2 to 4 gigabyte range, then it will take 5 minutes for the container to spin up if you have a lot of people spinning it up at once. If you have a container that has a lot of machine learning and other libraries, and it's a large, 12 gigabyte container, it's going to take longer for everything to start. So again, profiling, container management, making sure that everything is sized so that you can have a prompt start for a large crowd is very crucial. at APL, if for our up 24/7 science cloud with a bunch of scientists on it, we don't have 50 people logging on all at once. Even for the NASA one, where they have 125 plus users, I believe they said typically there's like 4 people on at any given time, 4 to 8 people on at any given time. So you don't have to worry about spin ups for performance and start time. But if you're running a pop-up workshop, you really have to profile so that you can have a scalable spin up time for the container fitting into the instance space that you're using. We did have one speaker complain about our small container size because they had a really crunchy problem they wanted to present and then have the students walk through. And they said, this problem is not scaling for 150 people. And we said, yes, please descope your problem rather than have us have to do additional resources because it's a tutorial. They're not full out research software engineers doing a full out analysis for a paper ready publication. So work with your speakers. It's as much a people problem when you're doing a workshop in the cloud as it is a logistics problem because people are part of logistics. So we actually told, we have 12 gigabytes in the machines that the students were using, and we told all the presenters, you have to be under 8 gigabytes of RAM because we knew, things creep up with that. Also, the cost. The speaker wanted to do this very large high RAM usage thing, and that would have moved into dollars per rather than pennies per for the notebook environment, which multiplied by 80 or 150 people really starts to add up. Alrighty, containers and conflicts. I've mentioned so much of this is right-sizing your container. We operate for this particular summer school, the PyHC Summer School, we use the PyHC setup. So Python in Heliophysics, again, is this organization that ran the summer school, and they are a front end to packages. There are 7 core packages that must be installed in anything that's a PyHC container. But there's 40 or 50 odd packages here, ranging from very specific to very generic, that may or may not be needed for an individual workshop, class, or the reason that you're spinning up your container. Don't install everything by default. Ooh, there's even more unevaluated. That will make too large a container size. So 7 core and 50 additional packages is too large a container, takes too long at 9 a.m. when everyone's spinning up their machines for that day's session. So test against the actual material that you're presenting in the workshop or event. It doesn't have to be 100% of the material if stuff comes up, because in the notebook environment, you can do pip installs of additional packages. But that will slow down the students. That will cause more sysadmin use when you have to help people when they run into problems, and there'll be network issues. So test against the tutorials. And I mentioned, speakers will break you because you make a perfectly performing container. And again, your speakers are going to, at the last minute, say, hey, I need to add Koopy because everything's faster with Koopy. Koopy, CUPy, is a NumPy accelerated for GPU usage. If you have GPUs, CPU will automatically accelerate NumPy under the hood without needing to know GPUs, which is fantastic. But you don't want someone to insert that last minute because the installation of it is slow and tedious because of the underlying CUDA libraries. And you're not providing GPUs in your workshop, so it's not needed. So you will have to work with your speakers. Obviously, speakers and presenters and teachers and educators, they're the content, they're the talent in Hollywood terms, and you have to make sure that they're getting what they need. But you can push back as the operator with realism and say, look, this will have impacts to what you're presenting. This will make everything slower for everyone. That perhaps your problem is not scoped for the time frame that you're at, which is often key. And also there's a certain, please play nice with other people. So again, we have a performing container, and we're working with PyHC to make a more generalized one for the community. And those of you in other science domains, obviously you're going to have your own multiple containers that you make available, but you do always want to juggle performance versus last minute customization and panic, because performance is both time and cost, and time itself is a cost. So we iteratively resolve dependency conflicts. Our base OS is off Pangeo, and most of our container is not actually the OS, it's all these libraries and support for heliophysics that we added in. When people said, oh, we also want to do a little bit with machine learning on the last day, there were some dependency conflicts because packages fighting each other and dependency issues are totally a thing. So we had to look at what's the risk of adding machine learning in. First off, do they need PyTorch or TensorFlow? If they need both, then we just say no, because that's a completely different scope. But if you're doing machine learning research, you might need to support both. We actually looked at, did we want to ditch Pangeo, our base image, and make our own lean stack just to save a few gigabytes and a few startup minutes? But Pangeo, which is evolved from Earth Science, and Earth Science is way ahead of Helio and Cloud, is regularly updated and good and stable. And we want to continue tracking with Pangeo. If you go to make your own container, you decide what you want to have as your base. But again, we had to hold the line on the image size, working with the community and the presenters. And we decided in the end that having a choice between 2 or 3 containers, such as here's your core container and here's your core plus machine learning, would be the good way to go for future workshops that we're going to run. There's a company called Navtech that has an open source dropdown that might already solve that. And one of our areas of development we're going to do in the next year is better selection of multiple containers for this kind of environment. And the other thing is we found communicating with the users, the people attending the event or workshop or class, if they know the expected startup time, they didn't complain. And that's a really important thing in the iteratively resolving. It's also working with the users. If you have 80 people showing up at 9 a.m. and you say, start up your environment, and everyone's twiddling their thumbs for 5 minutes, and they're like, it's not up yet. It's not up yet. You're doing a lot of support, a lot of crowd control that's not needed. If you say, hey, everyone start up your containers, it's going to take maybe 5 minutes for them to come up. So we're going to start doing some of the introductory material while they're coming up. They're very happy to wait because you've conveyed that expectation. So you don't have to be a superhero in this. You just have to convey realism to your user base when you're working with them. Onboarding. We preloaded all the user accounts with the content tutorial and the cache data so that as the tutorials went, they were already loaded. People didn't have to do GitHub fetches, and the data was there, so we weren't having 8 people all hammering the same data server at the same time, which always leads to slowdown. The catch with cache data versus fetching live is we had to tweak the caching. Usually, most of the packages we do, when they cache data, they cache it in a local directory in your user space. But we were not going to go through 150 signups and individually run the tutorials there to cache the data and have 150 copies of all the data sitting there. So instead, we used a shared disk as the cache. So there was one cache copy that everything drew from, which is a fantastic performance solution, very easy for maintenance. And then when tutorials got updated, the cache was there for everyone. The downside is the default for the EFS cache was anyone could read or write from the entire thing. So that meant people could accidentally overwrite the cache if you didn't do caching. So when you're doing onboarding and runtime of the event, think about your data strategy for things that are fetching data. Also, sysadmin issue. With the default settings incognito, when everyone was signing up, we had 150 registrants, 80 on site, I believe. There was actually a timeout because the default for Cognito limited 50 emails being sent for signups. This is one reason that for people attending here, I emailed out this morning information to get an account going so we could stagger the account signups just to avoid this kind of limit. Otherwise, you have to get a lot of effort. And Sarah and Peter had to basically work via the users in the room and Slack online to manually add people, which slowed down the start of the event. So you may think that your cloud is perfectly set up to run your 150 participants. Check AWS settings. They may bite you because they have certain hidden limits. Sarah ran into one the other day. She was doing some test installs, and apparently we have a cooldown period. We can only do like 10 installations before AWS is like, whoa, 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 cooldown before you do the next one. So there's some hidden settings in AWS that might bite you. So you will need someone for runtime support. But the more you do these things, the more you learn. And we've learned. In this case, you have signups. You have to use a custom SES identity. So we could assign up to 50,000 people versus the default 50. And again, this is because our load test didn't actually register 50 people when we did initial testing. Nice thing is, user sign up was staggered. That meant server sign up time was staggered. But because we had hot nodes there waiting, we actually didn't really have a lot of issues with node startup time. Runtime support. So here's a couple of dashboards from Grafana that we had up. For our specific one, here's our performance. We had a maximum of 88 servers running at any given time, and most users were in the 50 cents to $2. This is because we didn't have very intense high performance notebooks because it was a workshop for them to learn the PyHC packages and how to do research rather than crunching into 100 terabyte longitudinal problems. And in fact, a lot of the cost was from idle nodes because they were listening, then acting, listening, then acting. We were getting great metrics from this. This was one of the best performance tests and really informed our cost cases going long term. There weren't any real system problems. So our platform is very stable, and AWS has a pretty stable backing. So that went really well. There was one runtime error with the speaker. They were getting data from a mission called MMS, Magneto Multiscale Mission, and the MMS data server went down, and they were relying on that. So they had to skip past it. That was an externality. That wasn't us. It was an external server. The walkaway is don't rely on live servers during live demos. Try to cache data or have things locally as much as possible. And someone noted they were worried about, students figuring out how to navigate the cloud file system and learn notebooks. And then they were also worried about the solutions. A lot of them had a blank notebook, and then they had the solutions, the answer sheet. The speakers provide the answer sheets. They were worried about students just rushing to the answer sheets. Either the students found them and didn't misuse them, or they didn't find them. But either way, we actually found that if you provide solutions and hidden material, it's probably not a problem, especially if people are there to learn. So runtime worked very smoothly. And again, the nice thing about the cloud and having a stable cloud platform is we didn't really have to, once we tested and tested, we knew everything would work. The cloud is very repeatable. And we also knew if there were any problems, we would be tearing it down at the end anyway, and we can fix it the next time. If you are not already on PyHC Summer School, log in, sign up, register, log in. Hopefully you've started a server. I suggest the Happy Notebook as a good example of these are the types of things that people were doing at our workshop. Obviously, if you're doing this kind of stuff, yours will be different, but this is a standard notebook environment. If you're not super familiar with it, you have file browser on one side and your IDE, which combines text and code on the other. Text is just text and has instructions. Happy is the heliophysics API. It's a way of fetching time series data like changes in solar brightness over time or changes in Earth magnetic field indices over time. And you want to see like spikes when cool things happen. And this is what the speaker worked off of. They talked through the tutorial. I'm not going to talk through the tutorial because I'm not teaching you all how to be heliophysics, but this is a good example of a well-structured tutorial. It's a mix of code and text. It goes into the why of things and then has examples. It calls up plotting so that there's a high engagement. You can see, you don't even need to know what the data is to say, wow, there is stuff going on in this data over time. Time series are great for that. Images pretty images are also nice. We went a little into here's how to manipulate plotting, because plotting's important, doing other stuff. Interesting thing, this worked during the actual workshop, but it doesn't work now. So if anyone's actually walking through and they're like, hey, how come I can't connect to this data server? That data server is down. So that's the kind of thing that, speakers have to be like, alrighty, that's down. Hopefully I have enough material to make up for it. And then, they went to advanced stuff, and I'll get a little into recommendation, but they had suggested problems, and here's the solution, but they, often had the solution partial. So a good bit on structuralism needed for that kind of thing. Add-ons. We had an external person, Shawn Polson from PyHC, made an app that was a challenge ladder. It had a whole bunch of problems, and the idea was set the students loose. They can choose which problems, and they get points if they solve them. And here's one typical problem. Plot the latest solar image from SEO AIA. That's all it says, but based on all the material they'd had in the workshop, they hopefully had enough tools to solve this in teams. The nice thing is, Peter and the crew were able to incorporate his external challenge ladder into the cloud environment so that it was available to all the participants in the cloud environment, and it could all be tracked, et cetera. And you can see the winning team, and there's a scoreboard and such. It was somewhat brittle because this was a one-off application made shortly beforehand because it would be cool. And so there was some, roughness around the edge of it, but this was a JavaScript app that was able to be pushed into the cloud. So the nice thing is with the cloud environment, everyone being the same, you can also have other apps, especially JavaScript or web-based stuff, available to all the participants to add higher levels of engagement or interactivity. So those of you in an academic environment, you're not just limited to notebooks. You can put in, quiz or testing software or other tools that you want. And again, that developer, Shawn, was not part of the HelioCloud team. He was someone running the event, but he got working locally on the computer, and it automatically worked in HelioCloud, partially because he knew he had the container in the HelioCloud environment, so he knew the container and such, but also because Peter and the rest of the team put labor in to get it to automatically work. Sometimes automatically is other people. Costs. So PyHC was a workshop, 150 people, most on site, some remote, never more than, 88 people at any given time. And for the 1 week workshop, 5 days, 8 hours, it was $676 to run it. So if you're like writing a grant or trying to figure out what it would cost to do a massive cloud workshop, it was $164 just to get everything up and going. Sorry, it was roughly $500, $100 a day to run the cloud base. The notebook environments, the machines the students were spinning up and running notebooks on, typically were only about $2 per user per week, which is fantastic. So this means this scales really well. If you need to do something for 1,000 people, well, okay, $2 per user per week plus $500 for the base. If you have to do it for 8 people, well, $500 for the base and then $2 per user per week. So this gives you an idea for a average performant, not high performant, not HPC or supercomputing environment. We used a very high trust level plus real-time monitoring, which is the same thing that we're running here, which is to say, if any of you are trying to mine Bitcoin during the course of this demo, we don't have something that's automatically stopping that, but we do have a sysadmin looking at the stats and hopefully catching any exceptional usage. So we trust people to use it for the purposes while the thing exists, because it's all running off of one AWS account. All the bills are being paid off one AWS account. I think high trust works for workshops. In the case of this workshop, everyone had to register with an email address that sent information to them. So we have a valid one, and you're all registered for a conference. So this is the kind of thing that we feel good with this trust. But we sent you a URL, and if someone else got that URL and they made an account, what we have found is we haven't run into any malicious actors yet in this or our other clouds, but we do run into people that are unintentionally expensive. They call up a multiple GPU server on the cloud, and then they go off on vacation and don't take it down. And if we don't have an automatic shutdown, it runs up costs. Or they're creating models and they decide to do a massive parameter search of 100 times 100 parameters, and the next thing you know, they've made 10,000 1 terabyte models on the shared disk space because they didn't realize there was a resource limit. So unintentional things are what we find we have to do the guardrails and the watching for versus deliberate malice. Hopefully that'll be the same within your ones. But remember, especially if you have people that are new to the cloud, they may not realize that AWS lives on the microtransaction and that every access costs money. And if they're like, oh, there's a million files here, I think I'll do an ls-r on the files to see what it's like, that's going to cost $10 in AWS to list every file. And maybe there's a better way. Okay, use the APIs provided. So the scientist that knows a little is probably your most dangerous threat in terms of cost risk. We have hidden costs that are not as relevant for doing a pop-up or short-term workshop. We want to have better automation, maybe a sign-up gateway, remove snapshotting and backups. We find a lot of our long-term costs, a huge amount, 25 to 30% of our costs at APL is disk volumes that are not needed or not associated with an instance, but that we're paying for. Coming up with how to expire inactive users, totally a thing. Figuring out how to expire snapshots. When can you just tell people, sorry, we don't have a backup past this certain point. Sharing disks. If user Linko leaves, but user Antunes was relying on some of the files in their shared disk area, how do you decide on purge thing? There's lots of policy stuff, but the nice thing is for a workshop, you can ignore the entire lower half and you can just go with the upper half for it because not that many things are going to come up during your 1 week or might come up for your 3-month or 4-month sort of thing. Again, 80 plus concurrent users, under $1,000. If you want to do stuff that's more high performance computing, some other stats that we have. Running 2 terabytes of 120K files took 25 minutes with 50 cores and costs $8 a run. So if you have that as part of your, you set this up for a semester course and you have students doing multiple runs of 2 terabytes, lots of files, budget it, $8 a run. It's not that much if they're doing 1 or 2 runs. It's a lot if you have 20 students and each student is debugging their code on the full data set 10 times. Because you have 20 students at 6, doing 10 runs. You can do the math. Suddenly you're starting to get into hundreds of dollars. Why? Because AWS will charge you for everything. It's not like you buy a laptop and it's a sunk cost and you can now break it. They will charge you for file access. They will charge you for disk storage. They will charge you for checking if a file exists. It's a teeny fraction of a cent and you get the first million for free, but these things eventually start to add up. And then when you get to high-end multi-core GPU machines, like the one listed there, that's $34 for a half day. If you have individual researchers that you're allowing to do that, great. If you have 150 researchers and you make that available, you're like, oh, you could use the small notebook or the high-end multi-core GPU machine, and they're all like, my work's important. I will use the high-end machine. You're going to be racking up unnecessary costs. So that's something that you may want to figure out for what you're particularly doing. If you're doing a class where you need high performance stuff and you say setting up a workshop type environment for a 16-week class, consider only making the high-end machines available for the last month of it, for example, when they're actually ready to do production, is one way to build good habits on them, i.e. do not throw iron at something until you actually need it. And it's a good way to control your costs. Let's see, several smaller notebooks cost a lot more than a single massive notebook. Uh, oh, right. So this is for actually presenting material. We had some presenters that broke things out. So if you look in the tutorials volume, which should be available to you in the actual instance, there's like happy 01, happy 02, happy 03, happy 04. 4-part tutorial. Each one's nicely chunked. The people getting the material like the chunking because there's a pause point. You can do stuff topically. Retention is better. There are other ones, it might be the PySpeedS one, where they have a notebook that scrolls through like 20 different screens and has 10 different problems all embedded in it, several of which take a long period of time. There's no chunking. And if at any point they exceed the RAM and crash the notebook, they have to start back from the beginning. So if you're designing material for a workshop in a notebook environment, chunk it, do small discrete notebooks that are doing a single task, and then move on to the less. It's more effective in terms of performance. It's more effective in terms of people able to adapt and learn the material. Also note, if you're running a workshop in terms of presenting, go back and forth, have open places where the people can contribute the code. One deficit of this tutorial is I didn't put open places for you all to have hands-on with the code, which is why I tried to say, hey, feel free to work through some of the notebooks or explore the environment and look at what's there. You could be like, hey, what's scratch space? Oh, that's a scratch space that is completely writable by everyone. Hey, let's see what this Antunes person put in their scratch space. You can explore the system and play around within that regard. But generally, you want to have interactivity. The whole point of using a cloud environment is interactivity. So don't just say, here's a cell, run it and look at the output. Here's another cell, run it and look at the output. Let people actually code if you're giving them a cloud environment to learn research software engineering or coding. Feedback we got from the attendees, they liked it. They liked the workshop. They liked the cloud environment. They liked having breaks. Make sure that there are breaks. Live coding and how you structure your tutorials is useful. Intros were good. Pronouns on name tags was liked. The challenge ladder really engaged. If you look at the attendee feedback, the first thing is there's no complaints about the environment. Oh, I couldn't learn the environment. Oh, I couldn't use the environment. In fact, the environment was transparent. It just worked. So all of their things were about the event, which is kind of what you want. It might, as a developer, your ego kind of wants people to say, wow, the cloud environment was great and seamless, and I encountered no issues and was easily able to navigate it. And I like the highly performant container you made that balanced the amount of RAM versus what the demos used. That's all under the hood. If you do your job right in setting up a cloud environment, no one will give you compliments and applause. But you won't get abuse and help requests. So it all balances out. You get the satisfaction of it worked. All of these comments were about the soft stuff, the actual event, the meat of the matter, which is what you want. And having an environment like cloud where it's a shared environment that's collaborative really meant that they could focus on the material versus having to configure their own laptop. The contrast would be if we're like, okay, everyone, you have your laptops, great. Everyone hook up to the Wi-Fi. Oh, yeah, okay, we'll give you the passwords and all that. All right, you're going to have to set up a Conda environment. So type this or go fetch this from GitHub. Oh, if you haven't set up your keys for GitHub, then go here and do this. Fussing with environment is so last century. The cloud unified environment is much better for collaboration and getting to the work right away. So the fact that all of these comments were, about the actual runtime is great, because I'd much rather see people really like the axe throwing and escape room than people's main comments being, I couldn't get anything done because the computer wasn't working and I had to spend all my time configuring things. Alrighty. Closing out with questions, etc. Oops, I went over an hour, sorry. HelioCloud.org is the resource for just about everything. You can fork HelioCloud.org. It's on GitHub. It's open source, released under the MIT license. if you fork it, we get to see that people forked it and we get to go, yay. And we're always happy to talk and collaborate. We're funded for the next 2 years to continue developing the HelioCloud platform. And anything that's going on in other cloud domains will probably be worth filtering into here. So at this point, we are open for questions or comments. I noticed there were